We're going to do some reviewing here, lessons 4.1 through 4.3. If you look on page 229, the mid-topic checkpoint, let's look at number 2. Scatter plot shows the amount of time Adam spent studying and his test scores. Use the scatter plot for items 2 through 4. So number 2, what relationship do you see between the amount of time spent studying and the test score? So what relationship? We could say it's a positive relationship, would be one way of putting it. So we could say something like this, that it's a positive relationship, and so when he studies more, he gets a higher test score. Which is probably to be expected, right? Number 3, they want us to use the points they gave us from the line, and they're asking what the equation is for that. One of the points they're giving us is 0.60, which is one of the y-intercepts. If they didn't give you points, we would just be trying to look for points that the graph hits nicely. But 0.60 and 490 are definitely the nicest 2 points on the graph, so that was a good choice that they made with those points. So if we're going to find this equation, we need to find what our slope is. So slope is change in y over change in x. We could do 90 minus 60 over 4 minus 0. That'd be 30 divided by 4. If you divide that out, it would be 7.5 or 7.5. Or you could just reduce it down to 15 halves. So that's the slope of the line. And then remember our equation, y equals mx plus b. We need the slope and we need the y-intercept. We already know the y-intercept was 60 though, so slope is 7.5, y-intercept is 60. That means our equation would be y equals 7.5x plus 60. So then for number 4, they want us to predict Adam's test score when he studies for 6 hours. So for 6 hours, hours is our x value. So we're going to put a 6 in place of the x. So 7.5 times 6 would be 45. 45 plus 60 would be 105. So we're predicting he would get 105 if he studied for 6 hours. That's going to depend if there's extra credit or not, right? And obviously there's going to be a max amount at some point. At some point you're not going to be able to get more than a perfect score. So, obviously, studying for like 50 hours or something crazy is not really going to have any more benefit over, in this case, 6 hours potentially. If we look at number 5, that was number 4 we just looked at there. Okay, number 5, the scatter plot shows the mean annual temperature at different elevations. Which statements are true? Select all that apply. So the first thing they're saying, the majority of elevations are in a cluster between 1,250 meters and 2,250 meters. So this would be 1,500. So that looks to be pretty accurate. That's a lot of points right there. So I would check that one. There's a gap between 500 meters and 1,250 meters. I would agree with that as well. There's an outlier at about 50-21. 50-21, I'm not seeing any outliers, so I'm not going to check that one. In general, the mean annual temperature decreases as the elevation increases. So temperature decreases as the elevation increases, which means it's a negative relationship. Remember, if they do opposite things from each other. So that I would agree with as well. Okay, you go to higher elevation, the temperature is going to get lower. Page 247, we'll just mention a little bit of vocabulary here. So a couple things to mention. We've got outliers, are things points that are a lot separated from, quite separated from the other points on the graph. We've got clusters where we've got a bunch of points on a scatter plot, and then a trend line is something we draw kind of to get an idea of what's happening in our scatter plot. And actually none of those match up with the fill in the blanks here, so we'll just mention this bottom part. Describe the scatter plot at the right, use vocabulary terms in your description. So one thing we could notice here, we've got the experience and their vacation days. So we can see the trend line has a positive slope, so we would see there's a positive relationship between your experience and vacation days, which would mean the more years of experience, the more vacation days a person has. There's a cluster between 5 and 15 years, and there's a gap between 15 and 18 years of experience. That's not a huge gap there. I would say this is maybe a bigger gap between, maybe 20 to 30, 20 to 35 years. I would say that would maybe be more of a gap there. And then we do have an outlier here, which I guess if you consider that an outlier, maybe then we don't worry about that being called a gap. So an outlier of 35 years of experience. Page 248, we look at some things about lesson 4.1, which is on constructing and interpreting scatter plots. So scatter plots, basically we just take information and we put dots on a graph, and then we can analyze the information. If you look at their example off to the left here, it actually is maybe a little bit more meaningful of a problem than this other one on the right that we're going to do in a minute. So this table shows temperature and number of tickets sold at a movie theater, and they're looking for if there's a relationship between the temperature and the number of tickets sold. So if you look at this, it does look like there is some kind of a relationship here. We could draw a trend line that kind of approximates these. If we draw a line something like this, that would kind of approximate what's happening with the temperature and the tickets sold. So one thing that they talk about in the book here is about clusters. So clusters we've got when there are groups of points. So cluster between 40 and 65 degrees Fahrenheit, and then also between 80 and 95 Fahrenheit. And what we can kind of notice is as the temperature is getting higher, then less tickets are sold. This is what's called a negative relationship or negative correlation. There's a little bit of a gap in between here. If you'll notice as well, there's a gap where there isn't really anything in between there. So, we didn't really have many in-between temperatures there of like around 70 degrees or something, I guess, would account for that gap. And then we didn't really have any outliers. Remember, an outlier is something that's a lot different than the other points. So let's say we had a point way up here. That would be an outlier. It's like what happened that it was 100 degrees and we had, that many tickets sold when we were expecting not to have hardly any. Okay, maybe a special event that would have caused that disparity. But anyway, just some things to think about when you look at the scatter plots. So if you look over to the right, they have a table showing the distance in miles and the price of airfare in dollars. And they want us to construct a scatter plot. So those are a lot of points to look at. I'm just going to pause this for a second and go ahead and get those kind of put on there, and then we'll look at the results. Okay, so when we graph the points, they should look something like this. They're asking on number 2 if there's a relationship between the distance and the airfare. You'd think the further you go, the more it would cost for your airfare. So you'd think there would be a positive relationship, but those are kind of scattered around. That looks like it might be raining or snowing or something. So we could say there doesn't appear to be any pattern, so there's not any relationship between the distance and the airfare. Okay, so we could say no, make a complete sentence, but no, there's not a relationship between distance and airfare. And then there doesn't really look to be any particular clusters or gaps or outliers either. So like I said, the example that they did first, that was a little bit better to look at as far as giving us things to look at that we could analyze. Lesson 2 talks about analyzing linear associations. This is where we talked about drawing trend lines and then looking at whether we have negative or positive associations. Also, we talked about if they were strong or weak. So if you look at their example here, for this one, we could draw a line that kind of goes through these points. Again, drawing a trend line, we want, if some of the points are on the line and then about half of the others either above the line and half the others below the line is a good trend line. So this one definitely would be positive. And then since it makes a straight line, we could say it's linear, makes a straight line. And they're all pretty close to that line, so we could say it's strong. So positive, linear, strong relationship. If you write those in a different order, that's fine. So if you look at this next part, number 1, we could kind of draw a line through these points, something like that maybe. The points are not very close to that line necessarily, so that's kind of weak. It is negative because we've got a negative slope on that trend line that we drew, and that was a straight line that we drew, so we could say weak negative linear association or relationship if you want. Number 2, we could try to draw a line with this. It's not really going to be any kind of a straight line. This is more what's called a parabola that you'll learn more about in high school. But anyway, this is definitely nonlinear. If you said no association, that would be an okay answer too for that with what we've talked about to this point. Okay, but for sure nonlinear. It's not making a straight line at all. Lesson 3 was on using linear models to make predictions. So in some cases, what we're going to do is they're going to give us information. They may be giving us an equation, or maybe we have to come up with the equation, and then we're going to substitute something into the equation. So if you look at their example, they want us to predict the volume of a water tank, or after 24 minutes. So 24 minutes, that would be the x value. So they are substituting a 24 in place of the x in the equation, and then they're working that out, and they ended up getting 4/10. So the y is the volume in gallons, so that means we have 4/10 of a gallon of water in the tank after 24 minutes. So if you look at this example, we have information about the employees' wages. So we have the number of copiers that they've sold and their wages. So I guess they're trying to sell copiers. So number 1 says if an employee earns $570, what is the expected number of copiers sold? One way of doing that, we could try to look at the graph and look at for 570, that'd be up close to 600. And you could say that would be maybe about 70 copiers sold based off of that. If they give us an equation, though, it's going to be more accurate for us to use the equation to try to figure this out. So here's our equation, and it's saying if they earned $750, so that would be their wages. So we put 750 in place of the y, and then we're going to solve for x. So we subtract 120. I'm sorry, this was supposed to be 570, not 750. Okay, and then you divide that out and you get 75. So I predicted 70 based off the graph, but it was actually 75. So I was off a little bit, which actually, looking at it, I kind of just didn't go all the way to the line there. We probably could have gotten a little closer to 75 just by looking at the graph. But anyway, like I said, if they give you an equation, go ahead and substitute into the equation, even if you have an idea looking at the graph. Number 2, if the employee sells 100 copiers, what is the expected wage? So we'll just start with the equation again. And then if they sold 100 copiers, we're going to substitute that in place of x. And that would be $720. Since we have a graph, we can go ahead and look at that as well. We're saying $720 for 100 copiers. The problem is the graph doesn't go that far, does it? Okay, so you could try to extend this graph off to the side here and then, try to guess where that's going to be at. But again, definitely more accurate if we work it out by hand. So this gives you an idea of what we're looking at in lessons 4.1 through 4.3. Have a good day.